Hello and welcome back. This is Isaac and you're watching Reading ACT Prep. Now, last time what we were looking into was the natural science related topics, right? Or the passages. And so like I said last time, what we're going to do is we're going to try to look into a little bit more difficult concept in natural sciences. Maybe it's easy for some of you there or some of you out there, but it will be difficult for most of the students to understand what this passage is directly talking about, right? So it will require your basic knowledge on certain scientific principles or science topics, or maybe your basic knowledge on some of the people or some of the important figures in history who is related with this topic. All right, so let's take a look at that today. All right, let's move on to the first. The pages 326 to 327, those of you already read this and those of you already have practiced this should have a good idea and good knowledge on what we're talking about, right? But those of you who are looking at this for the first time should, this passage should present a little bit of difficulty in understanding what we're talking about. All right, so let's move on to the passage and see what we're talking about here. Natural sciences. This passage is adapted from An Anthropologist on Mars by Oliver Sacks, 1995 by Oliver Sacks. Now, of course, we're talking about Johann Wolfgang von Goethe, was an 18th century German poet and a philosopher, and he was also you can't really say he was just a poet. He was just a poet and he was a philosopher, but he was also a scientist because he studied a lot on the plants. He's also written books on plants, like a botanical sort of like a guidebook. All right, and he was also a lot of things, right? He wasn't just a philosopher. He wasn't just a poet. He was also a story writer. He was also a novelist. He wrote famous novels like Faust, or it's not a novel per se, but it's like in a form of poetry, in a lyrical poetry, right, with the meters and proses and everything. And so therefore, yes, Johann Wolfgang von Goethe, and then we have Hermann von Helmholtz, right, was a 19th century scientist and a philosopher. All right, so I guess we're talking about those two people and the importance they hold on this topic itself. All right, so if you know a little bit about who Goethe is and also who Helmholtz is, it'll be easier for you to understand this passage. But let's put that aside and let's try to read the passages as best as we can, right? Now, one thing that poses us a problem here within this passage or within this paragraph, or within these paragraphs, is that if you look at the one paragraph, it's quite long, right? The introductory paragraph is very long, and the second paragraph is also very long, and the third paragraph, or the third and fourth paragraph combined together are also very long, and that's the end of the paragraph, right? Meaning, if you were to read only, let's say, the first sentence and the last sentence of the first paragraph, and then the first sentence of the second paragraph, the first sentence of the third and the fourth paragraph, you really wouldn't have a grasping idea of what the passage will talk about. And that's what I'm worried about, right? And so if you see any of the passages that are, if you look at your book, I mean, this passage is like long, short and long, right? I want you to read all of the paragraphs, the first sentence and the last sentence, so that you can grasp whatever this passage is talking about, right? And you at least know where it leads to. All right, that's what we want to do today. All right, so let's go back to that first paragraph and see. It says Goethe's color theory, his Farbenlehre, right, which he regarded as the equal of his entire poetic opus, was by and large dismissed by all his contemporaries and has remained in a sort of a limbo ever since, seen as the whimsy, the pseudoscience of a very great poet, right? Remember, Goethe, right? That's German. Goethe is a very famous poet, and at the same time, he's a very, he was very much interested in the field of science, and he did have this color theory, right? Goethe came up with this color theory. All right. Now, if you remember, Goethe was he was a person who was living in the 18th century. Right, it says 18th century. It's a in the middle of 1700, so 1750 something or 1740 something to 1780 something. He was living in those periods, and if you know, human eyes were able to perceive colors, but there was, of course, at his time there was something called a in the 1700, let me see. In the 1700s, I don't think there was a prototype for the photograph, but in the 18th century or 19th century, there was a photograph, or there was a prototype for the photograph, which was called the daguerreotype, right? Where the daguerreotype was a silver plate, and you were trying to inscribe pictures on the silver plate, and that was the beginning of the taking of the photograph, right? So, anyways, Goethe's color theory was very much of a pseudoscientific notion for the contemporaries, and therefore it was totally dismissed at the time, right? That's what we're talking about. And of course, it will continue to talk about Goethe's color theory. And then in the last paragraph, or last sentence of the paragraph, we'll read somewhere from here, right? So the color constancy for him was a special example of a way in which we achieve perceptual constancy. I mean, you can't see it here very well, so refer to your books. Constancy generally make a stable perpetual world from a chaotic sensory flux, a world that would not be possible if our perceptions were merely passive reflections of the unpredictable and inconstant input that bathes our receptors. So I guess the color constancy, the Goethe's color theory kind of wraps it up and says that for him was a special example of the way in which we achieve perceptual constancy, generally make a stable perceptual world from a chaotic sensory flux. That's what we're talking about. So what he's saying is that we have all the colors around us, right? We have all these complexities or complexity of colors all around us. And what the color constancy is that we perceive our perpetual, our perception, right? Our perpetual constancy generally makes a stable perceptual world from a chaotic sensory flux. That's what we're talking about. So our eyes will, our brain or our eyes through our brain will achieve this very constant color schemes. That's what we're talking about, right? There are numerous of colors out there. Of course, colors are not really much more than a reflective, reflected, how do you put it? It's a reflective element, right? I mean, the light will hit that part. So, for example, let's say this is white, right? I mean, you have the black and white here. Now, of course, the wavelength of the light that we have here within this studio will hit on the actual pointer here, right? And because of the different reflective indexes, it will have different colors, right? For example, here, the reflective indexes will be, say, lower or higher, and therefore you have the black color, or rather you have the, reflective indexes different or opposite of that black, and so you'd have the white color, or not, not as same as the black color. Now we call this a visual spectrum where we see from red to violet, right? The human beings are able to see in that range of visible light rays, right? So that's what we're talking about. What he's talking about is that there are so many colors. It's just that we perceive it in different manner. We perceive it into a very generally, right? We perceive it in a generally stable perceptual world, right? That's what we're talking about. Or at least that's what Goethe's color theory is talking about, all right? Next, Helmholtz's great contemporary James Clerk Maxwell had also been fascinated by the mystery of the color vision from his student days. So I guess there's another person called James Clerk Maxwell, right? He's also a famous scientist. And he was very much interested, fascinated by the color vision theory, all right? And of course, in the last paragraph or last sentence of the paragraph, we'll read from here, Clerk Maxwell wondered if this was how colors were perceived in the brain by the addition of color separation images or their neural correlations, what functions in the brain as the color separation image, as in his magic lantern demonstrations. I guess he did this demonstration of the magic lantern, and he wondered if this was how the color was perceived in human brain as well, right? So we're talking about the perception of the colors within human brain, right? The color theory. And then Clerk Maxwell himself was acutely aware of the drawback of this edited process. Color photography had no way of discounting the illuminant, and its colors changed helplessly with changing wavelength of light, right? So we're talking about that now. Color photography, right? There was a color photography, 19th century. Remember, 19th century came about daguerreotype, and of course, color photography was probably experimented. And what we're saying is that there's something called the illumination. It's the light sources, right? Depending on the light sources, you'd have the different colors, right? The brighter the light, you will have the brighter the color. Right? So for example, I mean, you can try this at home. You can probably hold up an apple, a red apple, right? You can hold it under a very strong, intense light. You will have a lighter red. And if you hold it on a dim light, you will see, more of a blackish red apple. Although the color red does not change, the range or the visual intensity of the color of the red changes as the illuminator or the light sources change, and that's what we're talking about. This color photography had no way of discounting the illuminant, meaning illumination, right? There's no way that color can be perceived as it is without this light sources. That's what he's saying. All right, and then it says 1957, 90 odd years after Clerk Maxwell's famous demonstration, Edwin Land, not merely the inventor of the instant land camera and the Polaroid, so I guess he's the person who's invented the instant land camera and the Polaroid, but an experimenter. He's also an experimenter and a theorizer of genius, provided a photographic demonstration of color perception, even more startling, right? So he's done 1959, he's experimented with the color perception, even more startling. And then if you read the last sentence of the paragraph, we'll read from here. These demonstrations, whichever demonstrations that Edwin Land did, right? Demonstrations overwhelming in their simplicity and impact that demonstrated a neurological truth that colors are not out there, right, in the world, nor, as classical theory held, an automatic correlate of wavelength, but rather are constructed by the brain, right? So here, it's out there. Colors are out there everywhere. And what we're saying is that color perception is important. It's our brains that perceive the color as it is. I mean, it's an interesting notion, right? I mean, I've thought about that when I was younger. I thought, why is it that, we're able to see colors? Why is it that there are certain colors for different objects around me? Why is there a differences in color? Why is there a lighter or stronger color? And why is it that why is it that there are some people who are colorblind? Why is it that some colors are different? Some colors are perceived different for some people than other people? Because if you look at you can find this website. It's called the Color Quotient, I think. It's called the CQ Color Quotient. Well, where it does is that it will test your color intelligence, right? What it is that it will test you on your brain of how you perceive the colors. Every single people will achieve or perceive the colors in a very different way. All right, it's a very different way. That's one of the reasons why, especially for televisions, especially for the monitors, there's a different color set for different people of the race. This is very true. I can't say for details. You can find out the details on the website or whichever way you can find it. European color coding as versus the American color coding, North American color codings, and opposed to the Asian color codings are totally different. We perceive colors in a different manner, right? And I guess it has to do with our evolution. I don't know if it's if the evolution did this because throughout our globe, the amount of light that we receive are different, right? So for example, if we're living in the northern hemisphere, we perceive color differently because of the illuminations that it does have. Maybe we perceive the color differently than those people who are living in the equatorial lines or the southern hemisphere, because the amount of light that we receive, right, the amount of wavelength of the light that comes into our atmosphere in different locations of the globe are pretty much different, right? They're very different. And so therefore, I think the Asians will prefer more of a crisp, a very crisp, sharp contrast, or maybe a blundered or a smoother sort of a color scheme, as versus the Europeans will want a little bit more of a how do you call it, like a cyan color, like a little bit more of a blue tinted color. I don't remember exactly, but there are differences in the color schemes of the TVs that the companies will produce. I mean, this is true, you look it up. So that's what we're talking about, right? So if you have the background knowledge, you can say, oh, okay, the color theory we're talking about, right? It depends on not the color out there, color, but it depends on the color that you receive and perceive in your brain, right? And it's different from people to people, and it's different from races to races, all right? So that's what we're talking about here. So you kind of get it, although we've left out a very huge chunk and portion of the details. We're going to go back to it later on, of course. We know now what the entire passage is talking about, right? Again, I'm telling you, very important basic information or background knowledge would be an essential, it will play an essential role in solving natural science questions. All right, let's move on to the questions now and see if we can further this, all right? 31. According to the passage regarding Goethe's color theory, Helmholtz expressed which of the following attitudes, right? So, I mean, you can definitely tell which of the attitudes. Now, for example, Goethe's and Helmholtz, and you have the Edwin Land and so on and on. You have a lot of people. You have a wide range of the scientists from the 18th century to the 19th and 20th century, right? So what did he think? Helmholtz thought about Goethe's color theory as what, right? So that's what we want to know. Now, of course, you know that the first paragraph talks about Goethe's, right? Goethe's color theory. And the second paragraph talks about Helmholtz's great contemporary, or Helmholtz's theory, as well as Clerk Maxwell, and also the first paragraph talking about the Helmholtz or how he thought about the color theory as well. So what we want to do is here we'll find the name Helmholtz, right? The first time it appears is right here and right here, right? So probably we'll read this part and see what Helmholtz thought about Goethe's color theory, right? So here we can say from here, but science itself was not entirely insensitive to the anomalies that Goethe considered central, and Helmholtz indeed gave admiring lectures on Goethe's and his science on many occasions, the last in 1892. So we can tell that he gave an admiring lecture, meaning that he was very pro-Goethe, right? So therefore, the answer here will have to be, is it disbelief, or is it respect, or is it amusement, or is it skepticism? So you have that similar word, like respective and amusement. Which is it? It says admiring, so therefore it has to be respect rather than amusement, because amusement is simply you looking at monkey in the museum and saying, oh, I'm amused, right? And I'm pretty sure Helmholtz did not look at Goethe's theory or color theory as a monkey in a zoo, right? So therefore you can say it was a respect, right? Admiring, respect out, right? Respect. Okay? All right, let's move on to the next. 32. It can be inferred, so inference question, right? Doesn't really matter because inference question at this level is not much different to the questions like detail or any other questions. Clerk Maxwell in 1861 demonstrated the color image would not have been produced from black and white film emulsions without the use of color, right? So it can be inferred that in Clerk Maxwell's 1861 demonstration of color image. So let's take a look at that and see what that means, all right? So 1861, all right? We'll have to find Maxwell Clerk right here, right? So he's done some kind of a, say, experiment. We know that there was a demonstration that he held, right? This perceived brain and the addition of the color separation images and his demonstration, so magic lantern demonstration. So we'll take a look at this first, right? It says, he formalized the notion of the primary colors and color mixing by the invention of the color top, the colors on which fuse when it's spun to yield a sensation of gray, and a graphic representation with 3 axes, a color triangle, which showed how any colors could be created by different mixtures of the 3 primary colors. You know the primary colors, the cyan, the blue, the red, and the yellow, right? You can create whatever, it wasn't the yellow, I'm sorry, it was the green, I think. Oh, okay, I'm forgetting the primary color, but it's red and cyan, and I think it's yellow. Yes, if you mix yellow and blue, you will get green, and you will get, consequent colors. But anyways, that's the primary colors. And it says, these prepare the way for his most spectacular demonstration, the demonstration in 1861 that color photography was possible despite the fact that photographic emulsions were themselves black and white. He did this by, so this is the important part, he did this by photographing a color bow 3 times through red, green, and violet filters. What are the filters? The filters are, so in front of a lens, you will put a red, green, and violet filter, right? If you filter these out, then you will leave out these colors, or at least the colors that you see out there will be filtered through the red. And of course, because of the idea that the 3 colors, the 3 primary colors can make any colors, right? So red will mix with any color, and green will mix with any color. violet will mix with any color. You get the idea, right? So if you have the filter, so this is I'm hoping that you understand this. I'll move out a little bit so that I can show you this, right? So if you have the camera of the old days, right, you will see this camera of the old days. You have lens here, right, and you'll have let's say a flash, of course, necessarily not attached to the camera, but held on a person's hand. Now, what we're saying is because the emulsion itself was black and white, right? It was black and white. So therefore, whatever the light rays that bounce off of the object that you're trying to photograph, comes back to the lens. What it does is that it will just photograph the black and whiteness of it. But if you put a filter of red, the green, and the violet in front of the lens, what it does is that remember, all the colors, right? All the colors that bounces back from wherever you're looking to the lens, right? It will have like different colors, right? It will have like the blue color, it will have the violet color, it will have the yellow color, whatever else colors there are, right? The red will pick up, right? Red will mix with that color. And with whatever the color is, if it's mixed with red, it will show it onto the film. And green color will also do the same. And violet color will also do the same. And so therefore you have a variety of colors, right? Although the red, green, and violet did not show a fullness of color, right? Like the true color we're talking about, like Kodak's true film color, right? True color film. We're talking about color photography in a certain level. That's possible, okay? So that's the idea. So the filters were necessary, all right? So let's take a look at that then. So, which is it? Filters, triangles, tops, and slides? Of course, the filters here, right? That's the idea. The tops we're talking about is the color, different color tops, right? And if you spin it, you will see the gray color. That's the top we're talking about. The slides, not really. Triangles, we're talking about the primary color triangles, but that's not the idea we're talking about here. So it has to be the filters. The different color filters will give you a different view of the color itself, all right? Okay, so that's the answer. 33. As described in the passage, Guth's contemporaries for the most part regarded him as what? Remember, his theory was regarded pseudoscience, right? It was dismissed completely. So, mediocre poet whose most important work was as a scientist, theorists whose attempts at poetry were commendable but insignificant, leading poet whose contributions to the science were less noteworthy, leading theorists who overturned previously standard approaches to the scientific inquiry. So your answer definitely will have to be C. That's the only answer, right? He was a leading poet. He's more known as a poet, and his work in science was just perceived as pseudoscience, and it was completely ignored. So therefore, he's a leading poet whose contributions to the science were less noteworthy, right? People didn't really think much of it, right? Okay, good. Next. 34. The tendency to perceive objects as having a given color, right, such as the perception of an apple as red, even if it is red only in certain lighting, is an example of what Helmholtz referred to as what, right? So that's what you need to find out. Helmholtz referred to this phenomena as something. Is it the split beam filtering? Is it the sensory flux? Is it the color separation? Or is it the color constancy? So the best way of solving this question is to try to find these terms and see what it means, right? So let's go back to the passage and see what he meant, all right? So Helmholtz would appear probably somewhere here. This is something what we read down here, right? So we'll read from that. Helmholtz thought of discounting the illuminant, and this he saw as an unconscious inference or an act of judgment, though he did not venture to suggest where such a judgment might occur. It says color constancy for him was a special example of the way in which we achieve perceptual constancy generally, make a stable perpetual world from a chaotic sensory flux. A world that would not be possible if our perceptions were merely passive reflections of the unpredictable and inconstant input that bathes our receptors. So your answer will either have to be the color constancy or the sensory flux, right? So which is it when an apple held under a certain lighting is not really apple red, right? But it is nonetheless red. Is that a color constancy or is it the sensory flux? Of course, the answer will have to be the color constancy, because we're talking about sensory flux as in different colors have different world, different objects around us have different colors. But when we say sensory or color constancy, we're talking about making it and percepting it into our head, right? I don't think, so this is, I'll make it simpler, okay? So there's an apple, right? An apple which is red inherently, right? This is red inherently. The frequency of the light that it bounces back is always red, right? That's the idea. But how do we as human beings perceive it is the different idea or different story. So the light, if there are more luminance, right, if there are more light that bounces off, you will see a clear color red, because that's what we will perceive in our, I hope that's the eye, okay, so in our eyes, right, when it enters our eyes and into our brain, the occipital lobe of our brain, that's what it is, right? You get the idea. So when we say color constancy, we're talking about this process. The sensory flux is this process, sensory flux. All right, sensory flux is the actual like a color that's out there everywhere, and that's coming into our eyes. And color constancy is occurring somewhere here in the process, right? It's the color red does not change at all. It's just that our perception of the color red, because of the lighting, because of the illumination differences, because of this differences, that differences, we perceive it as different. That's what we call an example of what Helmholtz referred to as a color constancy. Okay? You get the idea, right? Okay, I'm hoping that you do. This is a difficult concept to understand. I'm hoping that you did understand this, all right? So color constancy, sensory flux is the actual sensory things that come into our eyes. But when we say red, even if it's red only in certain lighting, is what we call the color constancy. Okay? All right, moving on. 35. According to lines 14 and 17, the wavelengths reflected by the apple vary considerably as a result of what? So let's take a look at 14 and 17. Okay, 14 and 17. So again, it will talk about that part. All right, so here, Helmholtz was very conscious of the color constancy, the way in which the colors of the objects are preserved, so that we can categorize them and always know what we are looking at, despite great fluctuations in the wavelength of the light illuminating them. That's what we call sensory influx, right, or sensory flux. Now, the actual wavelength reflected by an apple, for instance, will vary considerably depending on the illumination, but we constantly or consistently see it as red nonetheless. This could not be clearly a mere translation of wavelength into color. There had to be some way, right? Helmholtz thought of discounting the illuminant, and this he saw as an unconscious inference or an active judgment. All right, so that's the idea. Then what would it be, right? So what would the wavelength reflected by the apple vary considerably as a result of? Is it the difference between viewers' right and the left eye? Nothing like that. Is it the distance between the apple and the eye? Nothing like that. Is it the viewer's ability to perceive red in different light, or is it the variation in the source of light reaching the apple? It sounds similar, right? So, but which is it? When he says wavelength reflected by the apple vary considerably as a result of viewers' ability to perceive red, or variation in the sources of light reaching the apple? Now remember, it always comes down to, right? It's D. It always comes down to a viewer's ability to perceive red in different light, right? That's what we call color constancy, right? Color constancy. Remember that, that's color constancy. I mean, here. The viewer's ability to perceive red in different light is what we call color constancy, where we already constantly know, we constantly have been fed this idea that the apple is red, and so therefore it is perceived as red in our brain. That's the judgment part of it. That's what we call consistency or constancy. But when we say reflected by the apple, right, vary considerably as a result of the wavelength itself, that's what we call sensory flux, right? So that's the variations in the source of the light reaching the apple. Right, that's the wavelength that is reflected off of the apple, and that's how varying in from the lighting sources, the actual light source, variations of the sources of light reaching the apple. Remember, we're working on this two idea, color constancy and the sensory flux, okay? Always remember that. All right, next one, 36. The term illuminant, as it is used in line 20, and elsewhere in the passage, refers to which of the following? Is it camera flash equipment? Is it the color theorist? Or is it the light that makes an object visible? Or is it light before it passes through a filter? Right? What is it when we're saying illuminant? We're talking about the light that makes an object visible, right? We're not talking about the light before it passes through a filter. No, we're not talking about that, but that's already a reflected, right? That's already a reflected light coming in. When we say illuminant, it's something that shines upon an object, right? So therefore, that's the answer. To just make it clear, let's go to line 20 and see if we can find this idea. All right, we've already read it several times, but just to give you an idea, we'll read that again. So it says Helmholtz thought of discounting the illuminant, And this he saw as an unconscious inference or an act of judgment, right? So what do you mean by discounting the illuminant? Discounting the illuminant is how the light sources hit upon the apple itself, right? So it says the way in which the colors of the objects are preserved, so that we looking at, despite great fluctuations, the wavelength of the light illuminating them, right? That's the illuminant. Something that is illuminating the object itself. That's what we're talking about. So the answer for that question had to be light that makes an object visible, rather than the light before it passes through a lens, right? Moving on to 37. What about the nature of color perception is described as a preoccupation of Helmholtz? Excuse me, the way in which, right? So what are we talking about? What about the nature of color perception is described as the preoccupation of Helmholtz? The way in which varying wavelengths of light stabilize the appearance of an object, or is it humans arrive at a notion of what color of an object is, or humans undergo changes in color awareness as they age, or is it one color becomes another when images are superimposed? What do you think we're talking about? The only thing that comes to your head right now should be B, right? Humans arrive at a notion what color of the object is. We talked about this. This is what we preserve, right? Colors that are preserved. No matter the illuminant shining upon the apple, right? We know that apple is red, and it always will have that red color. Whether it's a light red or it's a darker red, it's always going to be red. That's what we're talking about, the nature of the color perception, right? Helmholtz, the way in which humans arrive at a notion of what the color of an object is, right? That's what we call, I'm going to have to go back to the same passage. I guess that passage, that part of the passage is very important in a sense, right? So again, here, he says Helmholtz was very conscious of the color constancy, the way in which the colors of the objects are preserved, right? Colors of an object are preserved so that we can categorize them, right? Always know what we're looking at, despite great fluctuations in the wavelength of the light illuminating them, right? That's the idea. Helmholtz is thinking that yes, colors will be always preserved, and it will always be the same color, right? It's not going to change along the way, although there's an illumination. So what he's thinking is that if we get rid of the illumination, discounting the illumination, right? Where does the color come from? That's the idea, right? Okay. So your answer, despite everything else that appear here, it has to be humans arriving at a notion what the color of an object is. Everything else doesn't really make sense. Read it. Varying wavelength of light stabilize the appearance of an object? Not really. We're not talking about stabilizing the appearance of an object. Humans undergo changes in color awareness as they age? No, not really. Yes, there might be some changes of the color, but it doesn't really do so. I mean, it's not really what we're talking about. One color becomes another when images are superimposed? Not really. We're not talking, when we say superimpose, it's imposition of it's superimposed as in it's making it clear the picture or making the picture clearer. That doesn't mean the colors will change. It will just mean that blues will become bluer and the green will become greener, right? That's what we're talking about. So imposition, not really. So we're talking about humans arriving at a notion that what color of an object is what the preoccupation of Helmholtz describing the color perception, right? Nature of the color perception. All right. Moving on to number 38. Do you see how hard this is, right? 38. According to the passage, the relationship between primary color, the three colors that were mentioned within the passage, which are blue, which are green, and which are violet, now, and other colors can be best described by which of the following statements? It's all colors are either primary colors or can be created by a combination of primary colors. You know that already. The human eyes perceive primary colors first, then other colors. Is that true? Or is it primary colors were the first colors captured on film by the camera, other colors were captured later, more sophisticated equipment? Or is it primary colors emerge as a result of blending non-primary colors along the axis of the Clerk-Maxwell's triangle? Now, I mean, all sounds, okay, but the best answer will have to be this, right? You already know that by mixing the three primary colors, you can get all the colors. If I am right, today's primary color is red, yellow, and blue, all right? Or it's referred as cyan, and it's referred as it's brick red, so it has to be. I can't really remember. I'm not an art major, for crying out loud, right? But anyways, that red, and then you have that yellow, right? So that, or was it green? I think it was green per se. I am having trouble with yellow and green. If you know what I mean, right? I mean, you know that. So that's the idea. All colors are either primary colors or can be created by combination of primary colors, and that's what we're talking about, right? Basic knowledge or the background knowledge on the actual what? On the actual color itself, right? Or the photography itself. All right, moving on. 39. Clerk Maxwell demonstrated that color photography was possible even though at the time of his demonstrations what, right? So he demonstrated that color photography was possible even though there was a problem, even though there was a difficulty, right? So let's take a look at Clerk Maxwell's examples. That's appearing in the second paragraph of this passage, right? So Helmholtz's contemporary James Clerk Maxwell has also been fascinated by the mysteries of color vision of his student day. So he formalized the notion of the primary colors and the color mixing by the invention of the color top, which spun will gray, right, to yield a sensation of the gray and a graphic representation with three axes, a color triangle. Now, which showed how any other color could be created by different mixtures of the three primary colors. Now, this prepared the way for his most spectacular demonstrations in 1861 that color photography was possible, despite the fact that here's your answer, despite the fact that photographic emulsions were themselves black and white. He did this by photographing a color bow 3 times through red, green, and violet filters. Having obtained 3 color separation images, as he called them, he now brought these together by superimposing them upon a screen, projecting each image through a corresponding filter, right? Suddenly the bow bursts forth in full colors. All right, so what should be your answer then? It's easy, right? You've already seen that answer. So the relationship of the Clerk Maxwell demonstrated the color photography was possible even though at the time his demonstration was illuminants were thought to be stable rather than visible or viable or variable. Photographing emulsions were available only in black and white. You've already seen that answer, right? And then general public rejected the new technology as stunts with no practical application, or is it professional photographers were reluctant to abandon the established black and white aesthetics? And you already have the answer, which is B, right? You found the answers within the paragraph, and so that's the answer, all right? All right, now the last question. We're winding down real fast because I'm probably excited to tell you all these things, or maybe I'm just going too fast, but bear with me, all right? Here we go. 40. The 2 images that became the single image in Land's photography or photograph of a woman were obtained by using what, right? So again, we have to look into this. So Edwin Land appears in the last paragraph, so let's take a look at the last paragraph. I'm sorry we have to go back and forth. It will take some time, but anyways, here we go. So Edwin Land, he did this again, right? So unlike Clerk Maxwell, he made only 2 black and white images using a split beam camera so they could be taken at the same time from the same viewpoint through the same lens. So we're talking about the split image, so meaning the lens will be splitted. So, I mean, not the lens itself will be splitted. So the lens will be splitted, and inside the lens there will be in like the aperture will be like splitted so that you'll have the 2 viewpoints, right? And superimpose these on the screen with a double lens projector. He used 2 filters to make the images. One passing longer wavelength, the red filter, and the other passing shorter wavelength, which is a green filter. And the first image was then projected through a red filter. The second image, ordinary white light, unfiltered. One might expect that this would produce just an overall pale pink image. But something impossible happened instead. The photograph of a young woman appeared instantly in full color. Blonde hair, pale blue eyes, red coat, a blue-green color, and strikingly natural flesh tones, as Land later described it. Where did these colors come from? How were they made? They did not seem to be in the photographs or in the illuminants themselves. These demonstrations, overwhelmingly in their simplicity and the impact, were color illusions in Guth's sense, but illusions that demonstrated a neurological truth. The colors are not out there, but in here, right? So the red filter only, one red filter only showed the full colors. Of course, this was 1957, before true color was ever there. So the color itself was probably very, tinted. But, right, nonetheless, it should give you that it should give you that good idea. So how did Edwin Land do this, right? So Edwin Land was able to do this, a screen lit from the front and back, flickering light sources, one lens into 2 cameras, or one camera with one camera with 1 divided lens. Of course, the idea is 1 camera with 1 divided lens. I showed you the drawing, right? If this is the lens, it was like divided, not the lens itself, but divided, right? So therefore, you could have the 2 same photos, right? 2 same photos, one with black and white, and the other one with black and white as well, but different filters, right? Different filters. so that they can be projected onto a screen and of course splitted, and you can see that one would be full of color or while the other would be black and white, right? So that's the idea behind the photography. Now, again, it was a very short while I tried to explain everything, but if you had a little bit of a sense, or if you at least had a little bit of a background knowledge on the science itself, on the science of photography, on the science of color and everything, you were able to solve this question easy, all right? I'm telling you, this is very easy if you knew what we were talking about, right? If you don't know what they're talking about or what we're talking about, the topic itself, even reading this paragraph, even reading these paragraphs would be really a strain on you. You wouldn't really understand this, right? I mean, I bet that you haven't really asked yourselves a question on how the color came to be, right? How you can see in color and how the color came to be. Now, recently I've seen this YouTube video showing us that you know what a color blindness is, right? You can't really distinguish between green and red, right? And so that color blindness was able to be fixed by wearing a special eyeglasses with color, the filters that would filter through, right? So which means color blindness is not really a problem of, say, it's a problem of the perception, right? It's the perception. So colors, when perceived through, when the colors are perceived, it is our brain that messes up the colors, not the color itself that changes and fluctuates, right? So therefore, all these color blindness can be now fixed by looking through a lens, a specially designed lens with different filters, so that these people with color blindness can see, right? I mean, these are things that you need to look into carefully. Now, I'm not really judging you, but these days you're not really interested in those good ideas. What you're interested in your Facebook feeds, you're probably interested in what your friends are doing, what your friends that you haven't even seen, you haven't even met in real life are doing. I mean, that's something understandable. I see the urge to, like, connect to the people. I see that as well. But I would recommend that you look into the things that are happening around the world. I want you to look into the different news that's happening around the world. I mean, think about what's happening in the Middle East. Think about what's happening in the Asia, what's happening in North America, what's happening in Europe. I want you to take a look at it, right? I want you to know what's going on. I want you to also read scientific journals if possible. I don't want you to read it thoroughly. I just want you to read what it is talking about. I want you to read different social theories that's happening around out there, right? I want you to read different things that are being discovered every day, right? I want you to really immerse yourselves into the actual world out there rather than inside your Facebook or inside your Twitter or Instagrams and so on and on and on. I'm not judging you. I'm not saying those are bad. I'm just saying there is a certain dedication that you can have towards these things, these different SNSs, and you can also look into the world, right? I mean, these SNSs can offer you good things if you're looking into the right stuff, but most of the times you're looking at just funny stuff, entertainment stuff, what the celebrities are doing. I mean, I do care, but I don't really care, right? And you shouldn't as well. If you had any idea who Goethe was, right? Goethe was, and who Maxwell was, and who Humboldt was, I mean, all these things will help you out in answering these questions. Now, remember, these are not just reading. These are not just your reading skills. These are not just how you understand the reading, but it's your reasoning. It's how you reason, how you try to come up with, your understanding, your perception of this passage. If you have a background knowledge that can help you to perceive this knowledge or perceive this passage in a different way than anybody else does, then it would help you out in answering these questions, all right? So always take importance in knowing a lot of things. Not too deep, but even in a shallow surface, right? I want you to know a lot of things. I want you to be exposed to a lot of things, all right? Don't just think of it as, okay, I'm a science major, so I'm just going to know about science, or I'm an English major, so I'm just going to look at English only. Don't do that. I want you to broaden your perspective, all right? So anyways, the next meeting, we're going to go more into the natural science passages. We have 2 more passages to go. So after these 2 passages, like I promised, we're going to one of the practice tests, right? Which will be close to whatever you're taking in few weeks time or a few months time, right, you'll be taking the test, right? So I want you to practice this with me, and then we're gonna go after the natural sciences. We're gonna go into the entire reading so we can grasp what the patterns of the testing current testing is like. All right, so thank you for watching, and I'll see you next time. Bye bye.